Hello students, today we'll start the types of matrices. Last class we discussed about the basics of matrix, that was the definition of matrices, and apart from that we discussed about the different orders of matrices. And after that today we are going to study about the types of matrices. So see, when we discuss about different types of matrices, the first type will come your row matrix. The row matrix is a matrix having only one row. Only one row is called a row matrix. For example, you see, you can name the matrix as A. So write 2 minus 3. So this is a matrix, and you see the matrix having only one row. So this is called a row matrix, and we know that every matrix must have one fixed order. So this matrix also is having order. When you write the order, first you check the number of rows here. The number of rows you see only one row, so right here, one here, then one cross symbol, then you write a number of columns. See, when you check this matrix on the basis of the columns, the first element is 2. For this 2, we check vertically, this is lying in the first column, and next element is minus 3, that's lying in the second column. So this matrix having 2 columns, right here 2. So this is a matrix of order 1 by 2. Next matrix B, right, minus 7 0 5. This is a matrix having only one row. So here one you write order, and how many columns are there? So there are 3 elements in this matrix. So for each element you check the column. This element lying in the first column, this element lying in the second column, this element lying in the third column. So this matrix having 3 columns, so right there. So this is a matrix having one row and 3 columns. The order is 1 by 3. So these two are the row matrices because they are having only single row. Okay. Next you write column after row matrix, then column matrix. Okay. When you write a column matrix, so as the row matrix having row only one single row, the column matrix also, the matrix must have one single column. The right matrix having only one column is called a column matrix. For example, at matrix P, to 5 and 7 you write enclosed by second bracket. You can enclose by first bracket also. Either you can enclose first bracket or enclose by second bracket. So this is a matrix, and you see the matrix having, when you are discussing about column matrix, only you have to check the column, and the column matrix must have only one column. So this matrix you see, this is having only one column. How many rows no matter, but the column is only one here in this matrix. So this is called a column matrix. So here also you write the order. When you write the order, always check the number of rows first. So this element, this matrix having 2 elements. So element wise check their rows. The first element lying in the first row, this element lying in the second row. So there are 2 rows here cross. Then in number column is 1. So this is 1. So order is 2 by 1. Next matrix you write 6 minus 3 2 6 minus 2. This is also having a single column. So this is also a column matrix. To write the order for all the three elements, you check the rows. This is lying the first row, this is lying the second row, this is lying the third row. So there are 3 rows and only single column, etc. These are the examples of column matrix. The number 3 comes here, square matrix. Okay. For square matrix, a matrix having equal number of rows and columns is called a square matrix. For example, matrix X 3 5 2 0. So this is a matrix having 2 rows and 2 columns. So in this matrix, the number of rows and number of columns are same. So this is square matrix. So order will be 2 by 2. That is square matrix of order 2 by 2, or simply connect 2 also, because number of rows and columns are same. Then next matrix, you write matrix 5 minus 1 3 2 2 4 0 1 7. This is a matrix. Here also you see in this matrix number of rows 3, number of columns 3. This is also a square matrix 3 by 3. Okay, so you can say this is a matrix, square matrix of order 3. So like this you can check the square matrices. So write one note: a matrix suppose capital A, which is denoted by the symbol Aij and m by n. Order of the matrix is m by n, and the elements of all the elements are denoted by the symbol Aij. This Aij represents the elements of this matrix, and matrix having order m by n. If it is a square matrix, then the number of rows and number of columns must be same, and this is called a square matrix. Number 4, you write diagonal matrix. Okay, before discussing about diagonal matrix, the first you must know the diagonal elements of a matrix. So when you find the diagonal elements of a matrix, the matrix, first thing, the matrix must be a square matrix. Okay, and after that you can find the diagonal elements of the square matrix. So see here, these two matrices, this matrix and this matrix, these two matrices are both are square matrices. So when you find the diagonal elements, so these elements are called diagonal elements. And here also, when you find the diagonal elements of this matrix, here I'll give you an example here. Suppose matrix A 4 3 2 3 3 1 6 7 5. This is square matrix, and when you find the diagonal elements of this matrix, always you find these elements only. These are your diagonal elements. Okay, so the square matrix where all the diagonal elements are non-zero numbers and the non-diagonal elements are all zero is called a diagonal matrix. For example, matrix A 6 5 this should be 0 and here 0 4. See, this is square matrix of order 2 by 2 and these two diagonal elements are non-zero numbers and other elements, those are called non-diagonal elements. Non-diagonal elements must be 0. This is a diagonal matrix. Then for next example, B 6 minus 6 2, this should be all 0. Then 0 minus 5, this is 0. I'll write again. Matrix B 6 0 0 0 minus 5 0 0 0 7. This is a matrix. This is a matrix of order 3 by 3. So here you see these diagonal elements. These diagonal elements are all non-zero numbers, but the other elements which are known as the non-diagonal elements are all 0. So these two matrices are the examples of diagonal matrix. Okay, you can pause the video to note it down. Okay, now students, one question you take: if a matrix of order 1 by 1 is a diagonal matrix, the matrix order 1 by 1 means the matrix must have only one element. The matrix containing 1 by 1 order, that means the matrix containing one element is a diagonal matrix. The answer will be yes. For example, you see the matrix containing the element 4, which is order 1 by 1. So this is a matrix of 1 by 1. So this is also, we can say this, the matrix also a diagonal matrix. The next will come your scalar matrix. The scalar matrix is also square matrix first, you see. It is square matrix first, and after that, where all the diagonal elements are, all the diagonals are all same elements. All the diagonal elements are all same elements, and the non-diagonal elements are all 0. So it's called a scalar matrix. So this is also one type of diagonal matrix also. As a diagonal matrix, the non-diagonal elements should be 0 and the diagonal elements should be non-zero numbers. So here also in this matrix you see scalar matrix, this is also diagonal matrix because the diagonal elements are non-zero numbers and non-diagonal elements are all 0. So this is also diagonal matrix, but apart from that, this diagonal matrix having one special characteristic. The special characteristic is that the diagonal elements must be non-zero and also they must be same. They must be same. So this type of diagonal matrix is known as scalar matrix. So for example, you see example matrix. This is a matrix, square matrix first. Second thing, this should be a diagonal matrix, because you see the diagonal elements are non-zero numbers and the non-diagonal elements are all 0. Apart from that, the diagonal elements are non-zero and they are same also. So this example is scalar matrix. Here also you see square matrix, and you see the diagonal elements are all non-zero numbers, and apart from that the non-diagonal elements are all, here you see 0. This is diagonal matrix, and apart from that the non-zero numbers in the diagonal matrix, diagonal elements are all same. So this is also scalar matrix. So these two are the examples of your scalar matrices. Next comes your identity matrix. So identity matrix also is square matrix, and it can also be taken as your diagonal matrix. Okay, and definition you see a square matrix where all the diagonal elements are 1. The matrix was square matrix and all the diagonal elements must be 1, and the non-diagonal elements are all 0. It's called an identity matrix. Here also you see the square matrix first thing. Second thing is that the diagonal elements are all 1 and the non-diagonal elements are all 0. This is identity matrix. So this is also one special property of diagonal matrix only. So here also see this square matrix and the diagonal elements are non-zero and all are 1, and the non-diagonal elements are all, you see here, 0. So this is also called identity matrix of order 3, and symbol we use always I. I symbol is used to denote the identity matrix. And identity matrix order 1, that is the element 1, single element in the matrix, is also can be taken as identity matrix. After that, zero matrix. The zero matrix means the matrix having, if all the elements are 0 only in the matrix, then it's called a zero matrix. For example, you see for zero matrix, your symbol name will be a capital O of any order. It is not necessary that this should be a square matrix, not necessary, it can be matrix of any order. The single element 0 is there. This is also zero matrix. Here is this matrix containing all the elements 0. This is also zero matrix. Here also you see the matrix containing all the elements 0. This is also zero matrix. Next comes here equality of two matrices. Equality of two matrices. So you see two matrices are said to be equal. So when two matrices are said to be equal, if number 1, they may have the same order. Both the matrices must have same order. Second thing, the corresponding elements in both the matrices must be equal or same. Okay, then the two matrices are said to be equal. So based on the equality of two matrices, I have given a question here. You see these two matrices are equal. So both are having the same order, and also given that both the matrices are equal, under that condition you are asked to find the values of these two unknown quantities x and y. These unknown quantities are available in these two matrices. So how to find the values of these two unknown quantities x and y? As these two matrices are equal, so their corresponding elements will be equal. So this x lying in the first row and first column, so check the element in the first column in the second matrix. Here that is your -1. So your x will be, therefore x will be equal to -1, and to find y lying in the second matrix, its location is second row and first column. So in the first matrix also find the element lying on the second row and first column, that is your -2. So y will be equal to -2. Using that property, we can find the unknown quantities in both the matrices when the two matrices are said to be equal or given equal. Okay. Now, based on these properties, I'll give some questions. Assignment I'll give. You solve it and submit on the WhatsApp. Okay. For today, after this, so next time we'll start some new topic, that is addition of matrices and multiplication of matrices, and also subtraction of matrices. Thank you and have a nice day.